So let's introduce the concept of a tree diagram in probability with this exercise. So this exercise reads, a bag contains 2 blue beads and 3 red beads. A bead is chosen at random from the bag, the color is recorded, and the bead is replaced. And then a second bead is chosen and the color is recorded. Okay. So the first thing to understand is, why should we use a tree diagram in an exercise like this? We're going to have to use a tree diagram to illustrate the possibilities for this experiment. Okay. So for instance, first it says a bead is chosen at random from the bag. The color is recorded and the bead is replaced. Okay. As you can see from the exercise, there's 2 types of beads. There's blue beads and red beads. Okay. So let's start with this first. So when the bead is chosen, it can either be blue or red to start with. So in one of the possibilities, it can be blue. In the other one, it can be red. So red is denoted by R and blue by B. Okay, so that's the first one. That's the first bead that's chosen. And then it says after that, again, a second bead is chosen and the color is recorded. So whichever bead is chosen first, we go again. So this means that we need to extend the tree diagram one more time. So no matter which bead is chosen first, after that, it can again either be blue or red. And same thing if red is chosen first. It can again be blue or red. Okay, so that's our tree diagram. Now we need to write down the probabilities of each event happening. So for example, what's the probability of getting a blue bead on the first try or a red bead? Okay, firstly, how many beads do we have in total? So for this, we read the exercise. It says a bag contains 2 blue beads and 3 red beads. Therefore 2 plus 3 is equal to 5. So we have 5 beads in total. And then it says we have 2 blue beads, okay? Therefore, the probability of getting a blue bead when chosen at first is going to be the amount of blue beads over the total amount of beads that we have. So 2 over 5, okay? And we're going to write this down here, 2 over 5. And then what's the probability of getting a red bead? So again, it's going to be the red beads, so 3 over the total amount of beads, which is 5. Therefore, we write this down here, the probability of getting a red bead. Okay, perfect. Now, what about the next bead that's chosen? Now here it says that when the first bead is chosen, the bead is replaced, okay? So this means that, for example, if we've chosen a blue bead, we replace it with another blue bead. So this means that the total amount stays at 5. It doesn't change, okay? And there's still the same amount of blue beads and red beads. So essentially what this means is that we have the same probability of either one happening. Again, the same as before, right? So again, the probability of getting a blue bead is 2 over 5. And probability of getting a red bead is 3 over 5. And same down here. 2 over 5 and 3 over 5. Okay, so this is our tree diagram. So now we have the events and we also have the probability of each event happening. Excellent. So that's part A completed. Now let's move on to part B. Part B says find the probability that both beads are blue. Okay, so let's write this down. The probability, and then we open brackets, of the event happening. The event in this case is that both beads are blue. So we're going to write this down as blue, blue. So blue twice. Okay. Okay. Now, in order to find out the probability of getting blue twice, as you can see in the tree diagram, this is going to be this here, right? So the upper part of the tree diagram, we get blue first, and then after that blue, we get another blue. So this is the only part of the tree diagram that represents this, okay? And then we know the probability of each happening. So we know that the probability of getting one blue bead, is 2 over 5. And the probability of getting a second blue bead would again be 2 over 5. So in this case, we do 2 over 5 times 2 over 5 in order to get that probability. And if you plug this into a calculator, 2 times 2 is 4 over 25. So this is the probability of getting 2 blue beads. Okay, excellent. Now let's move on to part C. Part C says find the probability that the second bead is red. So this case is slightly different. So here we're only concerned about the second bead being red. So in this case, if we look at the second bead that's chosen, so if we look at this part only, you can see there are 2 instances where the bead is red. So in this case, we're going to have to find the probability of getting there each time. So in this case, it's going to be, so there's 2 ways of getting a second bead that's red, and that would be first getting a blue one and then a red one. So probability of BR, a blue one then a red one, plus the probability of getting a red one and then another red one, so PRR. Okay, right, so let's decompose this. So the probability of getting a blue bead and a red bead is equal to, so 2 over 5 is the probability of getting a blue bead and then a red bead, so times 3 over 5, right? Then if we calculate this, we get 6 over 25. Perfect. So this is the first one, and then the second one, so the probability of red and then red again, as we can see from the tree diagram, is 3 over 5 times 3 over 5 again. And if we calculate this, we get that this gives us 9 over 25. Excellent. And so we're not done yet, because remember, we need to add both these probabilities up. And so if we add both these probabilities up, we get that. So PBR, we said is 6 over 25, plus PRR, 9 over 25. And we should get that 6 plus 9 is 15 over 25. And if we simplify this, we should get 3 over 5. Okay? Excellent. So that's part C completed. So this is reserved for part B, and then we have the tree diagram. Perfect. Very good. Now let's move on to the second question. So this exercise reads, the probability that Tom takes the bus to school is 0.6. If he doesn't take the bus, he walks. The probability that Tom is late to school if he takes the bus is 0.1. The probability he is late if he walks is 0.4. So again, draw a tree diagram to represent this information. Okay. So remember again, tree diagram to illustrate this experiment. So first we have 2 possible outcomes. We have that either Tom takes the bus, which we can denote by bus, to school, or he walks. So walk. And then it says the probability that Tom is late to school if he takes the bus is 0.1. So once we know that Tom is either taking the bus or walking, so in this case taking the bus, he's either going to be late or not late. So those are the two outcomes after the first one. So we can denote late by L and not late by an L. And then the probability he is late if he walks is 0.4. So again, after he walks, he can either be late or not late. Excellent. So that's the first part of drawing the tree diagram. Now we need to write down the probabilities. So the question says, probability that Tom takes the bus to school is 0.6. Therefore, here we write 0.6, right? Probability of getting the bus. Then it says if he doesn't take the bus, he walks. So in order to find out the probability that Tom walks, we have to do 1 minus the other probability, okay? Because the probabilities need to add up to 1. So in this case, 1 minus 0.6 should give us 0.4. So the probability of him walking is 0.4. Okay. Now let's move on to the second period. So the probability that Tom is late to school if he takes the bus is 0.1. So in this case, probability that he's late after taking the bus is 0.1. And the probability that he's not late is going to be 1 minus the first probability. So 1 minus 0.1 is equal to 0.9, because remember it has to add up to 1. Then what about if he's walking? So the probability he is late if he walks is 0.4. So we write 0.4 here. And then the probability of him not being late after walking is 1 minus this. So 1 minus 0.4 gives us 0.6. Excellent. So that's the tree diagram drawn. Perfect. And then part B says, find the probability that Tom is late to school. Okay, so let's look at the tree diagram for this. The probability that Tom is late to school. So as you can see, Tom can be late twice, okay? He can either be late when he takes the bus, or he can be late when he walks. So in this case, the probability that Tom is late to school is going to be probability that he takes the bus, then is late, so B and then L, plus the probability of him walking and then being late as well. So we have two probabilities that we need to add up. And this would give us the probability of Tom being late. So let's decompose this again. So first we do the probability of being late after taking the bus. So PBL. So for this, again, he takes the bus, so 0.6 times being late after that, so 0.1. Very good. And so if we put this into the calculator, we should get 3/50. Perfect. And then the probability of him being late after walking is going to be, so 0.4, and probability of him walking, times probability of being late after that, which is 0.4 again. And if we plug this into the calculator, we should get 4/25. Perfect. So now we have both probabilities. So now we need to add these up. So if we add these up, we get 3/50 plus 4/25. Okay. And so again, if we plug this into the calculator or just do it manually, so common denominator of 50. So 25 to get to 50 times by 2. So we get 8 on top. So then we would get 3 plus 8 is 11/50. And so this should be the probability of Tom being late to school. Perfect. So now part B is done as well.